Today we going to focus on just a point of correction. We previously had covered the 2022 Columbia University Integration B qualifying round, and we looked at the 14 last problems. But it was brought to our attention by one of our subscribers at Get Chamlati that problem number 20 was not solved right. So today we go back and do some due diligence and solve this problem. So without much ado, let's move forward and make that correction. So the problem is the indefinite integral of the square root of tangent of x. And the first thing we'll do is to try and substitute for the tangent of x. So we say let u be equal to the square root of tangent of x, and that implies that u squared is equals to tangent of x. What this means is that 2u du dx would be equal to sec squared of x, and so from here we see that 2u over sec squared of x du is equals to dx, and since sec squared of x is the same as 1 plus tangent squared of x, what that means from this definition here, we see that 2u over 1 plus u to the power of 4. Previously we had made a mistake here and we said u squared, so it's u to the power of 4 du is equals to dx. So this is going to be the substitution we're going to make. Now, what that means is that the integral of the square root of tangent of x equals to, in place of the square root of tangent of x, we have u. In place of dx, we have 2u du all over 1 plus u to the 4th. So this means that our integral now becomes twice the integral of u squared over 1 plus u to the 4th. And so what is u to the 4th? We would like to break that down a little bit. When you have 1 plus u squared, that means that that is 1 plus 2 u squared plus u to the power of 4. And what that means is that 1 plus u squared minus 2u squared is equals to 1 plus u to the 4th. And we can use a difference of two squares because on the left hand side we have 1 plus u squared minus square root of 2u squared power 4, knowing that a squared minus b squared is a minus b, a plus b. Using this expression here, we can say that 1 plus u squared minus root 2 of u times 1 plus u squared plus root 2 u is equals to 1 plus u to the power 4. So we are going to use this to work on our integral. So now that we have our integral as twice u squared, integral of u squared over 1 plus u to the 4th, that means that our integral is 1 plus root 2 in the denominator plus u squared times 1 minus root 2u plus u squared, and the numerator is u squared. I could bring u here and put a large bracket there. So 1 plus root 2u plus u squared, 1 minus root 2u plus u squared, u. I am separating that because I want to create a partial fraction. I don't want to undertake a very long process of using variables. So we have u, and so the first integral here, I have 1 minus 2u plus u squared, 1 minus 1 over 1 plus root 2u plus u squared. And when I do that in the numerator, when I combine this, I have twice root 2. So I'm going to put twice root 2 here. And that means that all of a sudden, we do have 1 over root 2 out here. And we have u over 1 minus root 2 plus u squared minus u over 1 plus root 2u plus u squared. And that is where our integral has gotten to. So since we have 1 over root 2, 1 over 1 minus root 2u plus u squared minus, sorry, this is u, minus u over 1 plus root 2u plus u squared du. I could also re-express this as half times 2u, and then we have 1 minus 2u plus u squared minus half 2u 1 plus root 2u plus u squared du. Now we do have a missing something here, so let's just pull the 2 out here so that we have 2u 1 minus root 2u plus u squared minus 2u over 1 plus root 2u plus u squared du. Okay, we can even go further as to say, okay, if I'm to consider the numerator to be a derivative of the denominator, this would be 2u minus root 2, 1 minus root 2u plus u squared minus 2 plus root 2 over 1 plus root 2 u plus u squared. And now to compensate for what we've added here, we'll say plus root 2 over 1 minus root 2 u plus u squared, and then another plus root 2 over 1 plus root 2u plus u squared. Okay. So we've come to a point where we have our integral of 2 root 2, integral of 2u minus root 2 over 1 minus root 2u plus u squared minus 2u plus root 2 over 1 plus root 2u plus u squared plus root 2 over 1 minus root 2u plus u squared plus root 2 over 1 plus root 2u plus u squared. So these two parts can be easily integrated, and those will become 1 over 2 root 2 natural logarithm of 1 minus root 2 plus u squared minus 1 over 2 root 2 natural logarithm of 1 plus root 2u plus u squared plus 1 over 2 root 2 integral of u over root 2, sorry, of root 2u plus u squared plus root 2 over 1 plus root 2u plus u squared. But we can do that very easily, and also consolidate what we have here. So we have 1 over 2 root 2 natural logarithm of 1 minus root 2u plus u squared over 1 plus root 2u plus u squared plus half the integral of 1 over 1 minus root 2u plus u squared plus 1 over 1 plus root 2u plus u squared. Okay. 2 root 2 natural logarithm of 1 minus root 2u plus u squared over 1 plus root 2u plus u squared plus half 1 minus root 2 u plus u squared plus 1 over 1 plus root 2 u plus u squared du. We can rewrite this in such a way that we have u squared minus 2 over 4 plus 1, right? So that is equivalent to that. And here we can also write that as u plus root 2 over 2 minus 2 over 4, which is a half, plus 1, right? And so we have 1 over 2 root 2 natural logarithm of 1 minus root 2u plus u squared over 1 plus root 2u plus u squared plus a half 1 u minus root 2 over 2 squared plus a half plus 1 over u plus root 2 over 2 squared plus a half. Okay, couple of things that need to be noted. Let's rewrite that. 1 minus root 2 plus u squared over 1 plus root 2u plus u squared plus a half. And then we can pull this half out, and this becomes 2, right? So that we have in bracket here we have root 2 u minus root 2 over 2 squared plus 1 plus 1 over 2 u minus root 2 plus root 2 over 2 squared plus 1. I think that's a good place to transition. So we've come to a point where we have 1 over 2 root 2 log of 1 minus root 2u plus u squared over 1 plus root 2u plus u squared plus essentially 1 over root 2u minus 1 squared plus 1 plus 1 over root 2u plus 1 squared plus 1. And this is the same as log of 1 minus root 2u plus u squared over 1 plus root 2u plus u squared plus now 1 over root 2 arctangent of root 2u minus 1 plus 1 over root 2 arctangent of root 2u 1 plus c. Since we said u is equal to the square root of tangent of x, it's that our integral of the square root of tangent of x is equals to 1 over 2 root 2 natural logarithm of 1 minus root plus tangent of x over 1 plus root 2 tangent of x plus tangent of x bracket plus 1 over root 2 arctangent of root 2 tangent of x minus 1 plus 1 over root 2 arctangent root 2 tangent of x plus 1 plus the integration constant c. And that, ladies and gentlemen, is where this problem should have taken us. We apologize for that mistake we made, but I'm hopeful that this is helpful to whomever is interested. Until next time, bye bye.